Okay, so now you've developed your scale, it's time to actually assess how reliable your scale is at assessing the underlying construct that it purports to measure. So there are different types of reliability, and reliability is how consistent your survey is at measuring what it purports to actually measure. And the different types of reliability are inter-rater reliability, test-retest reliability, parallel forms, and internal consistency. And we'll have a look at all of these a bit closer now. So inter-rater is when the decisions from different raters, so a panel of experts within the field of what your scale purports to measure, are compared to each other to see how consistent the raters' decisions are. Yeah. Test-retest is when the same survey is given to the same group of people at different time points, and the results from time 1 are compared to the results of time 2 in order to determine how well the survey consistently gets the same results. So your Pearsons are between the two assessment times should be quite high. Yeah. So indicating that your latent variable is quite, or your scale is quite robust in its measurement. And also parallel forms, when the same group of people complete two similar versions of the survey. Each version of the survey is trying to measure the same thing, so the same latent variable. Then the results from the two versions are compared in order to determine the consistency of these results between the similar versions of the survey. And you would expect that to be quite high as well. And then you have internal consistency, which is the most relied upon reliability analysis of a survey. So internal consistency is when different survey items that are trying to measure the same construct are compared to see how they produce or how well they produce similar results. Yeah, so there are two types: average inter-item correlation, when a group of people complete a survey and all of the items on the survey that are measuring the same construct are compared with each other. Then the items are compared overall to create an average of those comparisons. So you get an inter-item correlation, which you would expect to be quite high amongst all of your items. And then you have split half, when a group of people complete a survey and then all the items on a survey that are measuring the same construct are split in half to form two sets of items. So you have the first half or the second half, or you have odd numbers and even numbers. And then the two sets of items are compared to each other to see if all consistently measure the same construct. So in terms of internal consistency, alpha is the most reported statistic within the literature. However, it is biased by the number of items in a scale, with a larger number of items typically associated with greater reliability. Further assumptions of alpha pertain to uncorrelated errors between items, multivariate normality, so it presumes automatically multivariate normality, tau equivalence, where each of the items have identical regression weights, as well as identical degrees of covariance between items. Remember, this was an assumption pertaining to PCA. So this is the downfall of PCA, and this is why you use EFA, because PCA makes the same assumption as alpha. Yeah, and you couldn't expect all of the items to be predicting a latent variable to the same degree. Yeah. Instead, researchers are now suggesting to use omega, and omega actually uses the regression weights and error terms of the items in order to calculate the internal consistency. And with EFA, you actually generate the regression weights and error of the items, and therefore can calculate omega. And if you're quite interested within this, there's an article by Dunn et al. That suggests why you should be turning towards omega as opposed to alpha for your internal consistency measure. And they also provide help in order to calculate this. But it's ultimately up to you, because the literature is still with alpha, but it is turning towards omega as a measure of internal consistency.